Hello, this is Jenny, and welcome to Crash Can Science. In this very special episode, we'll be going over chromatography. So, you might be wondering, what exactly is chromatography? Chromatography is a process in which a chemical mixture is carried by a liquid or gas and is separated into its components as a result of different properties and distributions of solids as they flow around in a stationary liquid or a solid phase. Before we go deeply into chromatography, let's go over some keywords that you have to learn in order to better understand the process.
Solid is the substance we separate during chromatography. Solid is what is being separated out of the solvent, which is the substance used for dissolving. The mobile phase is compared in a definite direction. The stationary phase is the substance fixed in place for the chromatography procedure. In this experiment, the mobile phase is water, the stationary phase is in paper, and the analytes are the various ion solutions.
So, as the point of this lab is to figure out the strengths of the Coulombic attractions in these different ions, we'll be actually separating them onto various chromatography strips. To begin, we need to prepare chromatography papers of roughly 6 to 7 inches. For this lab, we'll need at least 2 strips because there are 5 different substances, and each strip could actually have 2 or 3 depending on how many you put. First, draw a line roughly 1.5 centimeters from the bottom of the paper. And make sure that all of this is done in pencil, because if you do it in ink, the ink will travel along with the ions. On the strips, label them accordingly to the ions that you are putting on them. For example, manganese and iron. Now that we have both strips prepared, we can now actually start the chromatography experiment. Put the capillary tube into the solution and try to get a bit. Don't get too much, as we'll be trying to make the dot small but visible. Like that. Make sure it doesn't smear out too much.
What are you doing? I don't know. No, not like that.
Repeat for the various ions solutions. You have to redot them so that the color shows a bit more. Because these are ion solutions, the colors won't be as strong for each ion. You will need to make sure to go over them once after you're done. Make sure the dots aren't as big and are relatively concentrated with the pigments. That way, as the paper travels up, they wouldn't intercollide. Now you put some distilled water, roughly 1 centimeter, so that it goes below the line on here. And then you insert these strips into it without the actual pigments touching the water. Now, put a watch glass over it and let it set for roughly 10 to 15 minutes, so that by the time you're done, the water should be about 1 centimeter or 2 centimeters from the top of the paper. After the time is up, remove the watch glass and observe the strips. Some strips may be very faint to see, so it is important to mark them before you proceed. Draw a line from the solvent front, which is the distance the solvent has moved up, and then locate the points. From the center of the points, as in this one is right here, this one's a bit down, and then the manganese is even further down, and the green is here, and the nickel is around here. It may be very hard to see on camera, and that is why you have to dot them multiple times before you put them into the solution. So the final part of the lab will be you'll be giving a solution with 2 or more ions in it, and you'll have to decipher exactly what ions are within the solution using chromatography.
You will be given a mystery solution in which there are a mix of different ions. Using chromatography to separate out the solutes, you can determine which ions are in there. This works because each ion travels a different distance because the strength of the ion dipole forces with water varies according to Coulomb's law. So, by comparing the distances traveled by the solutes of the mystery solution, distances traveled by the known ion solution, you can figure out which ions are present.
Thank you for watching, and this is Crash Can Science.